welcome everyone to the 10th tutorial session of problem solving through programming in C. So this is a SWAYAM course which is floated by Professor Anupam Basu from Department of CSE IIT Kharagpur. I am Siddhant. I am one of the 4 TAs who are in charge of this problem solving sessions, where we will solve this sample questions from older assignments, and um this will probably and will also clear doubts, and hoping that this will probably help you out in solving the assignment questions as well as in the final exam. So in this week's lectures, that is week 10's lectures, the bubble sorting algorithm was covered along with some bisection method and a few other stuff such as using pointers and in functions and so on, call by value and call by reference, and all those concepts were covered. So let us solve a few questions regarding that. But before going to the topic at hand, I would like to discuss something from the previous lecture. So we had a question where an option was greedy algorithm. The question was that whether linear search, what kind of algorithm is linear search? So there were different options. Linear search was a brute force algorithm. Among the options, one of the options was this greedy algorithm. Greedy algorithm is an algorithm which basically wants the best possible option at all times. It's very greedy. It wants the best possible option at all times. So an algorithm that wants the best possible option at every iteration. So an example of the greedy algorithm is selection sort, because selection sort we require the lowest, we require to find the minimum amount, the minimum, if we are say arranging the array in a non descending order, then we find out the minimum value that is occurring among the elements in the array, and we bring it to the first place. So in selection sort we always go for the minimum or the maximum element, which is the best possible option at every iteration. So that is a greedy algorithm, which basically means that it wants the best possible option at every iteration. Okay, now that that is out of the way, there is another explanation I would like to do, that is regarding brute force algorithm. So brute force algorithm is basically one which goes over all the elements or all the options possible. So in linear search, we go through each of the elements one by one and we find out where our key is occurring. So that basically means that we are going over all the possible options that we have, and that kind of algorithm is called a brute force algorithm. Okay, so now that those things are clear, let us visit this week's topics, that is week 10's topics. So the first question that I have for you is that what is the best case efficiency in bubble sort? So bubble sort was something that is covered in week 10 lectures, and best case efficiency basically means that the input is sorted. So say if we want a non-descending order, our input would be something like this. So it is already in a non-descending order. So it is already in a sorted manner, and when we run the bubble sort in order to sort it out, we don't know that it is in this manner, but so when we do this bubble sorting, what is the best case efficiency of bubble sort? That is, how many iterations will bubble sort take to recognize that this array is sorted? So you have 4 different algorithms here as options. Just try to work them out and see which of this account for the best case efficiency in bubble sort. So let me tell you this, that for bubble sort the best case efficiency is order of n normally. So we have a boolean character here, or a boolean variable here, which is swapped, and we are initially setting it to true. And our array, when we are when we are traversing through the array for the bubble sorting, our swapped is also a condition that we have in the for loop, in the outer for loop. Only when it is true, this entire thing will go on to the next iteration. So once it gets false, it will just exit this for loop. So that has been done in all these three cases. Here it has been declared as false, so the for loop will not run at all. But among these cases, the for loop will be running, because if you remember, in for loop the condition checking occurs at the very beginning of the iteration. So in all these three cases the for loop will run, but you need to find out which of the cases, um, like which will give us the best case efficiency. Like the normal best case efficiency is order of n, but how can we improve that even further? So let us check that out. So okay, so this in this particular option B, we have a for loop going with the iterator j going from array length -1 up till j greater than equal to 0 while swapped is true, and j minus minus, and we are immediately declaring swapped as false, and we are running a another for loop from k equal to 0 till less than j, and we are comparing all the elements and swapping accordingly. But once we are swapping, say we are this entire part is the, we are basically swapping the numbers here in this entire part, but our swapped variable in the next case, swapped is still false, so it will we have not set swap to swap to true. So what will happen is it will automatically exit here. But is that the right way? Should that happen in the algorithm? Say if you had a actually a unsorted array, and we had something like this, that it would have simply exited from here because swapped is false. This entire condition, it becomes false. This is true, this is false, and it's a AND condition, so it would have been false, and the outer loop would have exited, which is not correct. For in case of this entire algorithm, it might work for the best efficiency case, but it will not work for a general unsorted array. So here the swapped actually should be declared true when we are swapping the elements. If we declare swapped as true, only then in the next iteration this it will go on iterating this. And if there is if it is in the best case efficiency, that is all the elements are in a sorted manner already, then there will be no swapping that is taking place, and this condition, this if condition will never be true, this entire part will never be executed, and swap will still stay false, and it will exit automatically. Okay, but not having this swap set to true here is a problem. Why? Because if there was an unsorted array and there was some kind of swapping that took place, the swapped and we have ignored the swap is equal to true statement. We are seeing option number B. So in that case, we would have in the next iteration it would have checked j is greater than equal to 0 and swapped the value of swap. So swapped would have been false, and this it would have exited the this j loop, right, which is actually not correct. So this is the correct algorithm for improving the best case efficiency of bubble sort. Is it clear to you? Now what is the problem with option D? The problem with option D is we are never declaring swap to be false, so it is true all the time, no matter what the case. Even if there is no swapping occurring, still it will be true, and it will keep continuing. So this is not the best case. Like, we cannot improve the best case efficiency of bubble sort in this way. Okay. Okay. So this is the correct algorithm for improving the best case efficiency of bubble sort. You can see how we have improved that, because it just needs to check the elements against one another only once, and after that it will, once it exits this k loop for the first time, so it will go through all the elements of the array once only, it will compare them. So those are the conditional operations that are taking place, and then after that it will find out that swapped is false because no swapping took place, and it will exit the entire loop, and it will say that the array is sorted now. Okay, so we are improving the best case efficiency. Okay, so let us go ahead with some other questions. Now this is, as you can see, this is a question related to functions, and this explained to us how call by value works. Now just go through this code, and uh, what will be the output of the following program. So here we have a variable y which has the value of 30, and we are passing that y to the function. We are calling the function called func with a value of y which is 30, and the value gets transferred to the function that is defined. It's a void function, and you should keep in mind the void function. That means it has no return value. Okay, so it does not return anything. Now it is taking some variable x here. So these are the formal parameters, alright, and this is the actual parameter. So these are just nomenclature. So the place where you have called the function, so the parameters that you are passing at the calling, wherever you are calling the function, those parameters are called the actual parameters. And in the function prototype, the parameters that you have defined are called the defined as inputs are called the formal parameters. So here what happens, we take this int x, which is the input to this function called func, and we change the value of x to 40. So once it comes here, the value becomes 40. But you can see here that this function is of void type, so there is no return value from this function, there is no return statement here, so it does not return anything back to the calling function. So here the main function is the calling function, and it does not return any value to the main function. So in this case the value of y will remain unchanged, it will still remain as 30. So this shows how call by value works. So call by value, what we do, we don't pass the address, rather we pass the value of y. So here when we call this func of y, it passes this value of 30 to the function. It does not pass the address of y. A different way of doing this would have been if we passed this. This is the address, we are passing the address of y here, address of variable y, and here similarly it would have been, say, int star x. So that means we are this function takes a integer pointer as input. Okay, it is still of void type, and then if we change the value of star x is equal to 40 here, and even if it did not return anything, it is still a function of void type, the value of y would have changed and the value would have been 40 here, because here the memory location y, so in the RAM somewhere we are storing the value of y, say this is initially 30, we are passing the address itself to the function. That means if we make any changes to the value at this address, then definitely this value will change, right? Because this address represents a single memory location in the RAM, and because we are changing the value of whatever is in this address to 40, this value will get changed to 40. And when we print what is the value of y now, when we say y, it immediately points to that particular memory location, which now has the value of 40 instead. So in this case, 40 would have been printed. So this is called call by reference. So we are referring to the address of the variable rather than the value of the variable. While here we are calling by value. That is, we are just passing the value of the variable and not the address. Okay, I hope that clears the distinction between call by value and call by reference. If you have any questions, you can just write it in the chat box, or you can unmute and ask. Okay, so let's go to the next question. So we have another C code here, a snippet, where we are defining a array, a 2D array, and we are trying to print some variables, print some values of the array. So what exactly will be the output here? We are trying to print some elements from the array. Okay, there will be 2 more sessions, I guess. It's a 12-week course, so we'll have 12 sessions. Yeah. So here we have a 2D array of size 3 cross 2, and we are initializing the array with some values, and we are printing some elements of the array. So what exactly should be the answer here? Okay, so this variable num is a 3 cross 2 matrix, as you can see here, with 3 rows and 2 columns. So when you represent it in this manner, that is, you initialize it without any double curly braces, it automatically divides it into the number of accordingly to the number of rows and columns you have. So it is a row measure format. Because C considers a row measure format of storage, so it will store in this manner. So we'll have 2 5, the first. Yeah, this is for C uses a, no, it's fixed. C uses a row measure format. So Fortran uses a column measure format. In Python you have options to take column measure or row measure, whichever you want. But yeah, C uses a row measure format. Okay, so we'll have 2 5 in the first row, then you will have 11 17, then 23 28. So this will be your matrix, which will be 3 cross 2 matrix, as you can see, 3 rows and 2 columns. And then what is it asking? It is asking num plus 2 star num plus 2 and bracket of 0. So what basically that means? So when I say num, simply, that is the address of the first element. That is, I can write it in this way, num 0 0. This is basically what, when I say just simply num, that basically it points to the first element, that is 2 here. It points to this first element of the entire array. Okay. Now similarly, when I say num plus 2, where does it point? It points to the, in the first is the, it's a like I said, the row comes first. So whenever you write this, whenever you write it in this format, so some num a b, so this refers to the row and this refers to the column, right? So similarly, when we say num plus 2 here, it will refer to the third row, that is, this is the first row, second row, third row. So it is num plus 0, num plus 1, num plus 2. So this is basically the address of 23 here, right? and now we do star of num plus 2, and then we write 0 here. So it refers to this particular row. When we say num plus 2, it refers to this particular row. In this context, when we put star, that is it. Now we are trying to say some value of some value that we want to find out, not the address, and we put a 0. And what basically this translates to, that star num plus 2 plus 0 another star, sorry, another star. So it's basically double star num plus 2 plus 0 whole star. So that basically means we are at the second, we are at the third row, and then we go to the first column, that is 0. It adds with 0, so it's the first column anyway. So this particular value is being accessed. So our the first printout here will be 23. That is, this is the same as writing num of 2 of 0. Okay. And similarly, if I write the second part, what will it be? Num of 1 of 0. Right? Star num plus 2 would be like it would refer to the entire row, but yeah, it will give you, it will consider plus 0, it will give you the address of 23. So basically, let me write it. Yes, but you are not using double star, it's a 2D array. So the format to write this is like this. So you are saying what will this give you, right? Star num plus 2, simply this, right? So this is a 2D array. So this basically, in some form, this translates to, if I write star yes, num plus 2 is the third row. So this is basically this, and what will that be? This will be this. So it is referring to the address of 23. So it's a, see, whenever you are writing 2D arrays, like num itself is a pointer of pointers. So okay, let me write that down. So when you say num, just num, without any square braces and numbers inside square braces, just you say that num, then this is a pointer of pointers. Okay, or pointer to pointer, you can say. So here, because it's a 2D array, you need to give 2 stars, because it's a pointer to a pointer. Now when I represent a single, when I write a single star and I say num plus 2, that means uh, the plus 2 goes to the first, to the major axis, that is the row major, this is a row major format, so it will go to the third row. It is num itself refers to the first row, then if I do num plus 2, then it will go to the third row, and third row you have 23 and 28. Now if I don't say anything after this, that means it considers a plus 0. So plus 0 means the first column. Now first column itself, but if I want to get the value, I have to give another star here in order to get the value, because it's now the second pointer that I am referring to. It's a pointer to the pointer that I am referring to. Yeah. No, it's not a value. It's address. It's address. Why? Because see, you can refer a element in different ways. Okay. If you want to use pointers to refer to an array, then you have to do it in this form. Say you are normally you would write num of 2 of 0, right? So it refers to the third row and the first column. Okay, the element which is in the third row and the first column. Now if you want to write this in the pointer format, that is using star and ampersand operators, that is referencing dereferencing operators, then what you have to do, first you reference the third row. How to reference the third row is you will write this star num plus 2. Now that will refer to the third row first column, and then you write whichever column you want it to. Say I want to move it to 28, so I'll write star num plus 2. Now it is referring to the third row now, then plus 1, that it is referring to the uh, yeah, to the second third row second column, but it's referring to, okay, it's not the value, I'm saying it's referring to. Now you put another star here, only then you get the value. Yes. So in this case, the first one is num of 2 of 0, which basically comes to element which is having the value of 23. And similarly, the second one, if I have to write it in a better kind of format, I would say this is num plus 1. Now, if nothing is written, no braces given, so I can still write it in this form, plus 0 and with braces, one more star before. So what is this exactly? Num of 1 of 0, that is second row first column, that is 11. So we have 23 comma 11, that will be the output here. So I'll have another question like this, which will be more complicated than this. We'll see it in maybe the next to next slide. So I hope you will answer it then if you have understood this one. Which one? In which? This one? Yeah, so see, there are different ways of referring to a value, of accessing a value from an array. Okay, you can, whenever you write it as num of 2 of 0 in this format with the square braces, it internally it converts it to pointer format only, because arrays, whenever your arrays are defined, they are defined with a variable which is also a pointer to the array. So when I have defined this short num3 of 2 is equal to something something, okay, then what it does internally, it generates a memory location of size 3 cross 2, okay, it generates this 3 cross 2 array, and it points this num, basically what it does, it points to the first element of the array. So say this is the first element, so this num will point to the first element of the array. The same is with 1D array also. So if I had a 1D array of say size 5, then whatever variable name I had, that basically, if I use that, that would basically point to the first element of the array. That is the definition of an array. Okay. Now there are different ways of accessing the values of the array. So I can, if it is a 2D array, I can give two square braces and I can write the row in the first pair of square braces. I'll write the row number or the row index, and in the second pair of square braces I'll write the column index. And what happens to this is basically this: it will convert, what it will do, it will increment the num by 2, that is, it will go to the third row, and then it will take whatever in the second part. So second part here it is 0, that basically, like I have written here, you can see this particular part. So when I write this of 0, that basically means it is like this: the star of, yeah, so star of num plus 2, that is the second, this goes to the second row. Now the num, which is the pointer, it goes to the second row, and then it goes to the plus 0. Plus 0 means wherever it is already pointing, it does not increment in the column direction, so the first column itself. So that is the value that it will return to you. Okay, so these are just different ways to write, to access an element or access the address of an element in an array. You can write it in either way. So you could have written here num plus 1 double star, or you could have written num of 1 of 0. Both will give you the same value. Okay. And this question basically is for explaining like how pointers really work on 2D arrays. So we'll even see a more complicated example a bit later on. Maybe we'll understand more there. Okay, so let's go to the next question. So we also looked into this a simple method for root finding. So this is a method which is used for finding the roots. That means where a certain function f of x becomes 0. So what is this value of x, right? What is the value of x for which f of x becomes 0? So how do we represent that in a kind of a code or something? We check where f of x decreases beyond some tolerance value, that is say 10 to the power minus 3 or 10 to the power minus 5. You can set tolerance value depending on your code. Once this condition is satisfied, whatever x value will have, that is the x. So we'll take kind of a tolerance value. Say if the value of f of x decreases beyond a certain limit, then we call that this is the root. Okay, so up till some certain accuracy we'll find the root. Okay, so I hope you are clear with how the bisection method works, because that is what is required to know here. So the first function that we have is y minus e to the power minus y equal to 0, and the roots are given. So the range is given 0 to 1. So we will have one root. We'll find the value of the function. So what is the function here? E to the power y minus e to the power minus y. So these are the two different a and b values, that is the range that is given to us. Now what we will do in bisection method, if you remember correctly, f of 0, first we'll calculate f of 0. So how much is f of 0? So this is 0 minus 1, right? So minus 1, right? Now we calculate f of 1. How much is f of 1? Anyone? Calculate it and tell me. So it has value of around 0.632. Okay. Now you can notice here that one value is negative and one is positive. So if this is a function which we are checking the value at 0 and we are checking the value at 1, and this is coming to minus 1 and this is coming to be 0.632, then somewhere in between there is definitely this root, right? Because it is passing through the value, at some point it has a value of 0 if on one side it is negative, and on the other side it's positive. Now what we do in bisection method, we have calculated the values at 0 and 1. Next what we will do is we will calculate the value at 0.5, that is 0 plus 1 by 2. This is the bisection of these 2 points. So what is the value of this function at 0.5? So the value is minus 0.1065 roughly. So this is again a negative value. So 0.5 occurs somewhere around here, I would say. So say this is not for directly scaling, but this is still negative. That means 0.5 is somewhere on this side. It is not. It is closer to the root than minus 1, but on the negative side. So what we will do next is we will take 0.5 and 1 as the two different as the range, and we'll calculate again the bisection or the centroid for this. Then 0.1 plus 0.5 plus 1 by 2, that is 0.75. Now what is the value at 0.75? So it's around 0.2776. Okay. Now okay, so now this is a positive value. So earlier we had we took the value at 1, which was 0.632. Now we are getting that 0.75 is somewhere around here, which has a positive value, which is 0.2776, right? Now what we will do is we will take, that means the root occurs somewhere between 0.5 and 0.75. So what we will do, we'll take the average of 0.5 and 0.75, and we'll calculate at 0.625. Okay, now what is the value at 0.625? So it's around 0.0897. Okay, following me so far? So it is still positive, as you can see. Okay, so it is still somewhere here. It is still not at the root, but it's still somewhere here, which is positive. It's 0.625, and the other so we'll take 0.5 and 0.625, one on the negative side, one on the positive side, and we'll again calculate the bisection. So what is the next bisection that we will be getting? So 0.5 plus 0.625 by 2, so it will be around 0.5625. What would be the value for this, value of the function for this? So it will be somewhere around minus 7.283 into 10 to the power minus 3. So this is fairly low. We can take it that the function has a root somewhere around this point, which is 0.5625, and here from the options you can see that the one which is closest to it is option C, which is 0.565. Okay, because all of this are more than 0.625, so the value will be greater than this. 0.655, 0.665 and 0.656 all are greater than 0.625, so the value will be more positive. But for this we will have somewhat a very low value, which is, you can see, 10 to the minus 3. So it is, the value is quite low, and we can say that the root is roughly at this point. So this is the answer for this particular function. So this is the root of this particular function, y minus e to the power minus y. So this is how you do the bisection method. Similarly, there is another question I have for bisection method. Here, say instead of y, let's say there is a function of t, and the function is t e to the power minus t minus 0.3. And what we have to do, the initial range given to us is 1 to 5, and we have to find the value after the second iteration. Okay, alright, so you need to find the root, not the function value. That is what it says. So similarly, what we will do, we'll find it at both the ranges first. So what is the value here? So 1 into e to the power minus 1 minus 0.3, right? So what is the value? 0.0678 or 79 roughly. Okay, what is the value at 5? So one thing you need to keep in mind, for bisection method, it is necessary that the ranges, the lower limit and the upper limit, should be such that one will always have a positive value and the other will always have a negative value. Only then you will be able to find a root which is occurring between the two lower limit and the upper limit. So here, as you can see, f of 1 is a positive value and f of 5 is a negative value. That means the root occurs somewhere in between it. Now we'll do the bisection of this. We'll calculate the value at f of 3. This is the first iteration. So this is what we are doing at the first iteration, right? So we calculate f of 3. Now what is f of 3? So it's around minus 0.1506. So it's a negative value, as you can see. So it is closer to the root than 5. So we'll take 3, and the other side, which is a positive value, is 1. So we'll take 1 and 3 as the new range. Now what is in the second iteration? Now we are starting the second iteration here. So what do we do in bisection method? We take the midpoint of the range that we have, that is 1 to 3. So our root value is 2 currently, like for the second iteration, and we find out the value of the function at 2. So how much is that? So that is around minus 0.0293. So it's again negative value, but it is, as you can see, it is closer to 0 than 3, than f of 3. So we are coming closer to the root now. So in the next step, what you would do, you would take 1 and 2 as the upper and lower limits, and you would calculate the value at 1.5. But we don't need to require that because that is in the third iteration. What do we need? What does the question ask? The question asks is whatever is the root at the end of the second iteration. So here this is the second iteration, and the root that we have found currently is 2. So here the answer is 2. Is that clear to everyone? How to do bisection method? All right, so let's move on to the next question. Okay, so here we have okay, so size of, we are using the size of function, which basically returns the number of bytes occupied by a certain variable. And what it is saying is a pointer or an integer basically is the size of an integer is 4 bytes. And so keeping that in mind, what will be the output of this particular code? So here we have defined 3 different macros, that is capital A, capital B and capital C, which are basically placeholders for integers 5, 8 and 2 respectively. And we define this, which is star x in bracket A, B, C in square braces. So what exactly will be the value of size of star x? So here you can try this out. Whenever you try this out actually on a compiler, you will see that percentage %d will throw some kind of error. So you can instead use percentage %lu, which is standing for long unsigned int. So that is actually the output of size of function is always it returns the output in long unsigned int, but and that is a bigger, that is a larger data type than int. So percentage %d refers to simply signed int. So percentage %d is a signed int data type, okay, which does not have the capacity to hold a long unsigned int data type, because long basically means it can go till higher number of digits. It takes more space, so it will throw some kind of error or some kind of warning. So if you face any issues, just change it to long unsigned, that is percentage %lu, and you will get the output of this particular code. Okay, so what should be the output of this code? Like, what is happening here? So what is clear from this is that we are defining an array. It may be an array of pointers or of integers of size A, B and C. That is a 3-dimensional array. So the total number of elements of the array, how much is it? 40, 80, right? So total of 80 elements are there in the array. Now if every element occupies 4 bytes of space, so that would be 320 bytes of memory, right? So here the answer is 320. That's pretty much clear. But what exactly is this? What exactly is star x? Is it an integer array? Is it a integer pointer? What exactly is this? So when you say this star x of say 10, okay, I am taking a simple case. So this what this refers to is an integer array of 10 elements, right? And in that case what you can do, you can just write x to refer to the address of the elements. Okay, and star x, whenever you write star x, that means you are referring to the value. Okay, so this is an integer array of 10 elements. Similarly here, when you write this refers to an integer array, which is a integer 3-dimensional array of size 5 cross 8 cross 2. This is an integer array. You can store the values. You can store values here in this array. This is simply an integer array that has been defined, and that carries the total. The size of this array is 320 bytes based on 80 elements that it has. Okay. Okay. So let's move on to the next question. So we have a integer again. This is a question regarding pointers. So we have a pointer which is ptr, a pointer variable, and we have a normal integer variable which has the value of 12. And what we are doing is we are saying that this pointer will point to the address of A. This is the referencing operator, I guess, if I remember correctly. So I don't remember exactly, but the star and this ampersand, this one of this is called a referencing operator, and other is called a dereferencing operator. So these are unary operators. So these are a kind of unary operators because they act on only a single operand, and they reference or dereference the particular variable. Okay, so here basically this operation, what it does is the A is 12, it is stored at some memory location. So I am defining a pointer which points to this memory location, that is A is equal to 12. Now where A is equal to 12 is stored, the memory location. Now what I am saying, the star PTR basically means the value, that is we are changing the value, that is accessing the value of this particular memory location. So I am saying star PTR is equal to star PTR, this is 12 minus 2 into star PTR, that is 12 again. So the value is minus 12 here. Okay, so the value of star PTR I have changed it to minus 12. That means the value of the memory location, the value stored in the memory location which this pointer PTR is pointing to, that has been changed to minus 12. And coincidentally, that is the place where this variable A had its value stored. So that value itself has been changed to minus 12. So when we print this out, %d comma %d star PTR comma A, we'll have minus 12 comma minus 12 as the output. So this basically refers to the concept of pointers. So I hope this has been fairly clear to you. Alright. Okay, so let's move to the next question. So this is the question that I was talking about earlier. So if you have an array element which is A of I, of J, of K, of L, so you have a array with 4 dimensions, okay, a 4D array you have, what would be the equivalent pointer expression for it? So you can access the elements of the array in this form, but what if I want to access the array elements in the pointer format, considering A is a pointer, or okay, so this is not ARR, rather it's A. Alright, so what exactly would be the array element? Thinking about the previous one, just think about the previous problem that we're tackling and try to convert this. So this is the first dimension that is going to be considered. So A, if you write simply A, it is referring to the first element of the entire array. Now I write A plus I, that refers to the ith element of the first dimension. Now I add a J here. Now that basically means that now it has moved to the jth element in the second dimension. right? Now I add a k here, so that means in the third dimension it is moving to the kth position. Okay, now I'm adding a L here, so that means it is moving to the lth position in the fourth dimension. So there I had a array which is num3 of 2, which had a size of 3 cross 2, and I say I wanted to access num say 2 comma 1. Okay, so I wrote num plus 2, so that moved to the third row of the array, and then I added 1 here, which moved it to the second column of the array, and then it returned, I put the star, so it returned the value at that particular memory location, that is this uh, third row and second column. So here in the first dimension I have to move by I units, that is I need to move to the ith position in the first dimension, jth position in the second dimension, kth position in the third dimension, and lth position in the fourth dimension. So first I write a plus I, similar to here. So I move to the ith position in the first dimension. Then to move, I need to move to the jth position in the second dimension. So I write plus j and I put another star. So jth position in the second dimension. Then kth position in the third dimension. Again, just repeat what you had done. So you put a star plus k in braces. Now finally we move in the fourth dimension to lth position. So plus L, and if you want to access the value, a star. So this will refer to the value of the array element at a of I, j, k of L. So as you can see here, this option is the correct one, which is matching with what I just wrote here. Do you have any doubts here? Okay, so that is everything I had. There is one more thing I had, but I think I pretty much explained this pretty clearly. So it's quite straightforward. You can just check it out. I'll have this added in the final cut also, so you can just look at this. So I have written what every star in this. So we have an array which is ARR of 1, of 5, of 3. So we want to access this particular element. So what are the things that come in between? Okay. So here, if I simply I write ARR, that means it is referring to the first element of the array, the very first element. Okay, that is ARR of 0, 0, 0, and the address of that, not the value itself, but the address. Now if I write 3 stars and ARR, that refers to the first element, the value of the first element of the array. Now what is star of ARR? That refers to the address of the first element of the array still. Okay, you can try this out writing the code. You can write in a code, and you can actually print it out and check whether it is the same or not. So ARR star ARR will give you the same thing. Now star ARR plus 1, what that does, it will just move to the second row of the array. Like I said earlier, it will just move to the second row of the array, and it will still point to the address of the first element of the second row of the array. Now what next? We need to go to the fifth index in the second dimension. So we do a plus 5, and both with or without the second star, it will still point to the address of the sixth element of the second row of the array. So index 5 meaning sixth element. So the address of the sixth element of the second row of the array. Now if we add a plus 3 again, that is we need to move to the third index in the third dimension, so we do a plus 3. Now this refers to the address of the ARR of 153, right? And we put another star, then we get the value of ARR of 1 of 5 of 3. I hope this progression is clear to you. If you want, you can go ahead and try, like try printing all these values. Take any array which you have set by yourself, and you can try printing all of these things and check whether it is actually giving the same output or not. Okay. All right. So that is all I had for this particular session. So uh, we'll meet in the next session. Okay, yeah, Avinash Kumar Mehta. So, will you can get this document as well as the recordings from in the course page. You can see live classes. There is now where the week one and all the week lectures are listed down. You can see a live sessions there, a live sessions option there. So once you open that, it will forward you to a page where all the links have been given. All the links are there. You can find the recording links also on there being uploaded to YouTube, and you can find these documents also on Google Drive, so you can just check them there. Okay, then that will be all for today's class. We'll meet next week at the same time, Tuesday 6 to 7, for discussing the week 11 questions. Okay, thank you for joining.